Hello my dear students, this is Akash SD and welcome to the ASD Physics classes. Hope so you are doing really great. So students, in this video we are going to learn about relation between electric field and electric potential, and we will also learn from the graphical point of view also, from the mathematical point of view also, and some general relations also, like why electric potential decreases in the direction of electric field. All these things we are going to learn in this complete video. Okay students, so let's see here. The topic is what? Relation between electric field and potential, and you can see from the potential difference concept. This concept we have learned in a last video, but we will just see here one time again from the not that much basic, but okay, we'll just see that here in a simple way. So what is there? You know very well, this charged particle will experience one electrostatic force. In which direction? In the direction of the electric field. That means this charged particle is having the tendency to move in the direction of electric field automatically by itself. But what we will do here, this charged particle we will take in the opposite direction of the electric field by applying some external force here. Okay, so let's take A is the initial point and B is the final point. So potential difference between final point and initial point, that means this VB minus VA is given by work done by external force per unit charge. That means we can write, students, simply W external, where to, students, initial to final point, that means A to B by Q. Okay students, now what happens that here, if in case this charged particle is moving slowly, there is no change in kinetic energy, then what will happen that here in this situation, this from the work energy theorem, this work done by external force will be what? Negative of work done by electrostatic force. Okay, hence what we can write here, we can write here, students, this VB minus VA is equal to minus WE by Q. This is our very basic. Now what will happen that here the displacement is where to where? A to B. If this displacement is very small, then potential difference will be also small, work done will be also small. So for very small displacement, what I am telling here, for very small displacement, okay, for very small displacement, what this will happen here, this will become potential difference dV, very small difference. Work done will be also small here, so we can write here dWe by Q here. Okay, now students, after that what we can write here, see, dV equal to minus 1 by Q. Work done formula, it is the dot product of force and displacement. Which force? Electrostatic force. So Fe into dr, general way we will write here. Okay, now students, after that what to write here, see, dV equal to minus 1 by Q. Force means charge into electric field into dr here. See, I am writing even in a bracket even. Okay, so that you should not get confused. Now what will happen right here, this Q and this Q will cancel out. Hence we can write here, see, this dV equal to minus E dot dr. This is the general expression. Okay, general expression. Now students, will write some formulas related to this. What are the formulas are there to solve the numericals? First one, as I have got dV equal to what is there, minus E dot dr here. Okay, and here we'll put the integration sign. And whenever we are using this expression, please remember that very well. If electric field is given in terms of I cap, J cap, K cap, then what will happen that here, this dr will be how much? Dxi cap plus dyj cap plus how much? Dz k cap. Remember that here, that is called the displacement vector. Okay, now students, here this formula we have to use when electric field is given and we have to find out the potential. In second situation, this formula is there, E equal to minus dV by dr here. This is the vector quantity, so we'll write here the r cap here. This formula we have to use when potential is given and we have to find out the electric field. Okay, even in terms of the rectangular components here. Okay, that means we can tell in 2D or 3D in any situation. In a rectangular component form, what will happen that here, this vector E will become here minus, remember that, this del V by del x I cap plus del V by del y j cap plus del V by del z how much? K cap. This formula we will write down here. Okay, so all this formula we should know to solve the numericals from this area. Okay, so see students, remember negative sign indicates that. Now we have seen that dV equal to minus E dot dr. Minus is coming everywhere, so see, this negative sign indicates that in the direction of electric field intensity, what will happen? Electric potential decreases. Remember that very well. Now students, this thing we have learned, but I just want to tell you two important cases that is very, very important for our future references and all that. So see here students, first thing is what? Let's take this is the electric field, okay, and here what is there here? This is charge Q is there, okay. So what will happen that here? This charge Q is having the tendency to move this side here. This charge Q is having the tendency to move this side here, okay. And as I have seen, we have seen what will happen in the direction of electric field potential decreases. That means if this is point A and this is point B, and we know very well VA is greater than VB. So what we have got that, remember that very well, positive charge always moves from high potential to low potential. What I am telling? Again, positive charge always moves from high potential to low potential. Similarly, in second situation, let's take this is the second situation here. Again, see, this is the electric field here. Now, this is the electric field here. Now I have negative charge here. Negative charge is here. Okay. So again, students here, if I take here again some points are there. Let's take here. This is point A, and for example, this is point B. Again, we know very well what is there. The VA is greater than VB because in the direction of electric field potential decreases. But now this charge will move in which direction? It is having the tendency to move this side here, this side here. That means what we have understood, negative charge always flow from low potential to high potential. Again, I am repeating, positive charge moves by itself from high potential to low potential, and negative charge moves by itself from low potential to high potential. Remember that very well. Okay, students. So now we are ready to solve the question. We will see JEE 2020 question. Let's go through the question, students. See the question. If electric potential at any point in the space is given by V equal to 3x square, then what is the electric field? Which formula we have to use? Number of formulas we have seen, na students. So we'll write here this formula. See, vector E equal to minus dV by dx into I cap. Why we have used this formula? Because it is given in terms of x. So what this will become here, students? Let's see here. This vector E will become here minus d by dx, and here just put the value of V 3x square I cap. Hence, what is coming here? This electric field is coming here. Differentiation of 3x square, 3 will come outside, and differentiation of x square, 2x. So 3 into 2x, how much coming here? 6x. So minus 6x I cap. Just put the value, students, here. So hence, electric field equal to how much? Value of x. How much to put? X value 1 here. You can. This is x, y, z. So x value how much here? 1. So students, it will come here minus 6 I cap. Unit volt per meter, or even you can write Newton per coulomb also. That means by seeing this, we can tell that there is the 6 volt per meter electric field in which direction? In the negative direction, in the negative x direction. Okay. So just see very well in how much easy way we have solved JEE 2022 question. Now students, next one here. This is a JEE 2019 question. We are going to learn very basic. So let's see here, students. See, the electric field in a region is given by, what is given? Vector E equal to Ax plus B I cap, where E is in Newton per coulomb and x in meter. The value of constants are A is 20, B is 10. If the potential at x equal to 1 is V1 and x equal to minus 5 is V2, then we have to find out what? We have to find out, students, V1 minus V2. So here electric field is given and we have to find out what? Potential. So students, again I'm telling that here, see here, this dV equal to minus E dot dr here. Integration. Okay, now this dV minus electric field value Ax plus B. A how much? 20. B how much? 10. So right here, please see 20x plus B value 10. 20x plus 10 I cap. So dr, what will write here? Very easy. We have to just write here dr as dx I cap here. Okay, just see very well. Now I cap dot I cap, how much? 1. So we can write here, see, this integration of dV is equal to minus, and here students, what this will become here? 20x plus 10 dx. Okay, so we can write here, see, 20x into dx minus, what will happen here, students? 10 into dx. 10 into dx. Now we'll put the limit, students, here. Limits where to where? X equal to 1 means V1 and x equal to minus 5 means V2. We have to calculate V1 minus V2 here. Okay. So let's take here I have taken here x equal to minus 5. Here also x equal to minus 5. And what will get here? What is the potential here? X equal to minus 5, V2 here. This is the V2. Okay. Now what is there? For x equal to 1, how much? V1. So here 1, and here how much here? V1 here. So that directly we should get here V1 minus V2. Okay, students, so what will happen here? See, integration of the dV means how much? Integration of the dV means V, and here V2 to V1 is minus 20. Integration of x dx means x square by 2. X square by 2 here, and put the limits please here. Where to where? Minus 5 to 1 minus 10. Integration of the dx means x. That means x. Where to where? Students, here again minus 5 to 1. So students, after that, just what will happen that here what will become here? This is V1 minus V2. When you will put the upper limit, lower limit and all these things now. So students, when you will solve here, it will come here very easily. It will come here 180 volt. Very basic thing is there. Just put the value and you will get the answer. Answer here how much here? 180 volt. Okay, very easily we have solved this question. Next one is students, NEET 2015 question is there. Let's go through it. If potential in a region is expressed as how much? 6xy minus y plus 2yz, then electric field is how much here? At which point? At 1, 1, 0. So students, here by seeing the question we know very well here we have to use in a 3 dimension. Okay, so 3 dimension students, what is the formula is there? First we'll write the formula here. Let me write here the formula. Vector E equal to minus, this formula we have to use it, delta V by del x I cap plus delta V by del y j cap plus delta V by delta z k cap here. Okay, this is the formula, and here we'll write the values here. So now students, after that just let's see one by one. First we are going to calculate this here, del V by del x. Even in our gravitation videos also I have done this, but okay, we'll see here. This means dV by dx, and what is constant students? This y and z is constant. Okay students, so let's see please, this d by dx and value of v how much? What is the value of v students? See, 6xy minus y plus 2yz. Remember that here what is constant? Y and z is constant. So students, here what will happen? As y is constant, so we can write here 6y and here d by dx of x. Okay, after that minus d by dx of y plus 2 into d by dx of yz. Now what other things are constant students? Let's see here. This is constant, differentiation of constant how much? 0, and here it will become here 6y, because d by dx of x how much? 1. So we have got students this del v by del x how much here? 6y, and value of x how much here? 1. That means here we have got here students, see, this del v by del x, just put the value of y how much? Value of y, value of y is here, this value of y is 1. So it will become here students 6 Newton per coulomb. Okay, 6 Newton per coulomb we have got here, that is del by del x here. So even by checking the option also we can get what is there? The option we have got del v by del x na. So which option is correct here? If you put the value here, see, minus 6 I cap plus, so where del v by del x 6 is matching here? Where students? See, this one here, this 6 is there, but after that we have to calculate del v by del y also, because here 9, here 5, so further also we have to calculate. Let's see students one by one. Now students, we will see del v by del y, because option we couldn't able to match here. So see here please, this del v by del y means second one students, we can write here what? This dv by dy, and here what is constant students? This x and z is constant. Okay, so let's write here d by dy, value of v how much? Value of v how much? See, 6xy minus y plus 2yz here. So what to write here? 6xy minus y plus 2yz. Now let's see one more time. Yes, correct only. Now good. So now students, what is the things are constant? X and z is constant. X and z is constant. So we can write here students. Let's see, x and z is constant now. So we can write here, see, this 6x and d by dy of y minus d by dy of y and plus 2z into d by dy of y. Okay, so what this will come here? 6x d by dy of y means 1 minus 1 plus 2z. Okay, hence this del v by del y will come what here? 6. Value of x how much? 1, even I remember, you can check backside, plus 2. Value of z how much? Value of z how much here? See, the value of z is how much? 0 students here. So just let me put here, let's go ahead here, the value of z how much here? 0. So students, what is coming here? if you will check out here, this is 6 minus 1, how much coming? 5. Our del v by del y is coming 5. Okay, so we'll write here, see here please, 5j cap plus something will be there. But now we can reach to the answer very easily. What is the correct answer? Option D is the answer. Okay, but I will just tell you, in a homework you can do, even if you will do del v by del z also, what will happen that here? This will be dv by dz, and what will be constant? This x and y will be constant, and definitely you will get the answer what? It will come 2. Okay, so remember that here how much easily way we have done this question. Okay, great. Now students, all this we have finished this. Now very easy question for the NEET and JEE point of view. Let's see here. A circle of radius r is drawn in a uniform electric field as shown in the figure. VA, VB, VC and VD are respectively the potential at points A, B, C and D on the circle. Then find the relation between A, B, C and D. Very easy. We know very well, in the direction of electric field potential decreases. Okay, so we know very well potential where will be maximum? Definitely at point D. Potential is more compared to point B, because here and here we can see. Now students, after that, if we will see here, let's take here, if you draw this line here, so you know very well potential at point A is equal to potential at point C. Okay, and these points are coming in the middle. That means finally what we'll get here? Potential at point D is the maximum. After that students, this VA is equal to VC, and here after that what is there? VB. The concept is what? In the direction of electric field potential will decrease. Okay, great. Second last, see. Very easy for NEET and JEE question. See, the electric field E is constant in both magnitude and direction. Consider a path of length D at an angle of theta equal to 60 degree with respect to the field lines as shown in figure. The potential difference between points 1 and 2 is given by how much? Okay, so this is a diagram here. So students, we know the formula. What is the formula? E equal to minus of dv by dx, but okay, but I am writing here del v by del x, because in x direction. Now students, after that, see, this electric field is given by minus, in the direction of electric field potential decreases. That means what to write here? Delta v na, that means final minus initial. Final is 3, initial is 1. So I am writing here, see, v3 minus v1. Okay, and let's take this distance, how much here? X. Okay, after that what will happen? That is here, this E equal to minus potential at point 3 and potential at point 2 is same. In the previous question also we have seen that. So what we can write here? See, v2 minus v1 by how much? X. X value from this triangle, how much? We can write here d cos 60. D cos 60, students. So when I simplify this, what will happen? Potential difference between point 1 and 2. 1 high potential, 2 low potential. So we can write here v1 minus v2 is equal to ed cos 60. Which option is correct? Just guess and tell me. The correct answer is here. Option C is the answer. Okay, great. Now, students, see here. Again, the variation of potential with distance x from a fixed point is shown in figure. The electric field at x equal to 13 meter, how much? So what will happen right here? This 13 meter will come somewhere here. Okay, students. So here you have to remember this relation from the graphical point of view also. Okay, like this thing here. First thing, see, dv equal to what we have learned that here, minus e dot dr. First thing. So here what will happen that, students? The graphical significance of integration means area. So potential difference will be given by area under ER curve. If this is x means, then area under EX graph will give always potential difference. We are seeing the graphical. Okay, students. Second one, we have done this one here, E equal to minus dv by dx. Now, most of the time this one will use it. Maybe dv by dx, dv by dy, but most of the time this. And what is the significance of differentiation? Slope. That means minus slope of which curve? Slope of Vx graph. Okay. And in this question, students, we have to use this one here. This one we have to use here. Okay. So hence, this electric field is given by minus slope. How to get the slope here? See, this slope. The line is the having the constant angle. Okay. So here points, students, how much you see? 12, 30. And here how much at this point? 16, 10. Okay, so slope means it is given by, see please, finals minus initial. 10 minus 30, that means this one, 10 minus 30, v2 minus v1 by 16 minus 12. Okay, So what this will become here? Minus, and again 10 minus 30 how much? Minus 20. 16 minus 12 how much here? 4. So when you will simplify this, E is coming how much here? Plus 5 volt per meter. Plus 5 volt per meter here. Okay, students. So remember that here, even point 13 is there, 13.1 is there, 12.5 is at any point. If we take any point between this one here, x greater than 12, less than or equal to 16, in this region, what will happen? Electric field will be same value. How much here? Plus 5 volt per meter. Which option is correct here? Option C is the answer. Similarly, if they ask in this region, from 2 to 6 also, electric field will be positive value, okay, because again slope is negative, and here in this region potential is not changing, that means electric field will be how much here? 0. Remember that, all these basics.